we talk about the volume flow rate for the circular bearing test. Okay. So we have already derived the flow rate for hydrostatic bearing and also for the air bearing. For the gas one is the air bearing. For the liquid one is oil hydrostatic bearing. And we can ignore the slot bearing. I mean, so restrict slot restrictor is not critical in application. So, so far we only discussed the two plates are parallel. We didn't discuss if the two plates, the top plate and the bottom plate, if they are not parallel, this is related to the hydrodynamic. Okay. So this is not the scope of our course in this semester. So most of the time in hydrostatic bearing application, we assume these two plates are parallel. Okay. And we also can consider another situation if the top plate is moving with constant speed. Top plate is moving in the right direction. The velocity. In that case, we can also calculate the velocity induced viscous flow equation. Because in the beginning, we always consider the pressure induced viscous flow. 我们考虑前面是考虑压力造成的流体流动。So we also consider the top plate moving with a constant speed. Then we also need to calculate the velocity induced viscous flow. 如果上平板它有移动速度的话，它其实也会造成我们的流量会变大。So this is the case when we are in the hydrostatic light table. The table is moving with a constant speed. So this will also reduce some viscous flow and also increase the volume flow rate for the bearing. Okay. So this is the general case. You need to consider the pressure-induced viscous flow and the velocity-induced viscous flow. In more general case, it's not parallel plane. So, but in the hydrostatic bearing, design, usually you consider those top plate and the bottom plate, they are parallel. So if they are not parallel, then the Rydell equation will be three-dimensional. So it will be more complicated. Partial derivative equation for the Rydell equation. Okay. So this is the top plate with the velocity. This is the case. If the velocity is equal to zero, okay, if the top plate is not moving, 所以这个是梅洛方程是在三度空间。如果它的上平板不是平行的话，通常我们用3D 来考虑。如果是平行，我们把它考虑成一度空间，其实是2度空间，只是把它的厚度考虑成固定的厚度。那这个是上平板有数字，下面是这个 U 的比，所以等号右边就可以。So last time we talked about this, the uh, the conservation of the mass. So the mass passing through the restrictor will be equal to the mass passing through the bearing area. Okay? So this is called the conservation of the mass. 是能量守恒，流进这个轴承的流量要等于流出去的流量。So this M restrictor equal to M bearing. So it actually is the mass flow rate， 其实是流量，它不是质量，它其实是 M dot。所以你如果写 M dot 的话，会比较清楚。流进等于流出啊，质量守恒。By using this, you can calculate the recent pressure. Okay. So we have this. If we assume the density rho for the lubricant oil is remain constant during the process of flow in, flow out. Okay. In that case, this equation can be transformed into this equation. This is the mass flow rate, and this is the volume flow rate. So the volume flow rate multiplied by the density of the lubricant will be equal to the mass flow rate. So in this case, we can derive the volume flow rate for the hydrostatic bearing and for the air bearing. And last time we also mentioned about the restrictor. We have capillary restrictor falling into the category of the laminar flow. Okay, so for the laminar flow is the Reynolds number of the viscous flow. This Reynolds number is smaller than some say 2,100, some say 2,300. This book, the textbook says the Reynolds number should be smaller than 2,000. Okay, even more strict number for the rhino number. So the capillary restrictor is a laminar flow restrictor. So for laminar flow restrictor, the rhino number should be smaller than 2000. Okay, so this is the constraint for the laminar flow. For laminar flow, you can check the rhino number. If the number is smaller than 2000, we call it the flow is in the region of laminar flow. Okay, but in some textbooks, sometimes they will put the number 2100 or 2300. In this book, the textbook is even more restrictive number, so it puts 2000 in this case. So this is a laminar flow restrictor, it has a capillary and also flood restrictor. For turbulent flow restrictor, it's already in this case, the random number will be greater than 2000. Okay, so here we have this random number in height. Right? This is the velocity of the flow, and this is the diameter of the capillary restrictor. And this is the lubricant viscosity. This is the viscosity of the lubricant. Okay. So we can check the random number with the capillary restrictor using this equation. Okay. There's also a constraint here. We have this one. So this one, the random number should be less than 2000. And also we have another constraint for the capillary restrictor. The ratio, so the ratio, the length of the capillary restrictor divided by the diameter of the capillary restrictor should be greater than 100. This is the constraint for the restrictor. So this is another equation for the volume flow rate passing through the slug restrictor. Okay, the first one is for the oil hydrostatic bearing. The second one is for the air bearing. Both apply to the circular bearing test. This kind of design. Right. And the third one is for the orifice restrictor. We have two orifice restrictor. This chapter. We have first one is called the simple orifice. Another one is called the annular orifice. So this one you should buy a small component, orifice component. Okay. And this one you can select machining by drilling a hole with diameter with a PR. And the film gap thickness is H in this circular bearing. Okay. And last time we discussed about for the orifice restrictor, the volume flow rate can be calculated by using this equation. And for the discharge coefficient here, CD, normally you should obtain this CD by experiment. Okay? 通常的话就是你必须做实验得到那个 CD 扩散系数。通常就是我这个节流器，我就是找几个出来测，大概平均值就可以测出它的实际。那这个也是一样，就是加工的口。So this is the experimental result obtained from the literature. You will see for the orifice restrictor, it's a turbulent restrictor. So the real number will be more than 2,000. This is 1,000. This is 2,000. Okay. So the real number should be greater than 2,000. And in this area, I think the CD was falling between the number of 1655 to 165. So it's between these two numbers. So this is the 2,000. So we should mark this 2,000. So this is the range of turbulent flow. we have this 155 is for the random number 100,000. 1 million. Random number equal to 1 million. So for the random number greater than 10,000 is about 55 years. So you can calculate the volume flow rate using this equation. So this is for the oil hydrostatic gas. Right. This is for the air bearing. For the air bearing, the theoretical formula for the volume flow rate or mass flow rate is more complicated than the oil hydrostatic bearing due to the compressibility. 因为气体的可压缩，所以它体积流率或流量流率的质量流率的那个公式的话，空气轴承不会比一阶压轴承复杂。理论计算来讲的话，是空气轴承会比一阶压轴承，一阶压轴承大部分的使用的范围都是不可压缩。So last time we discussed this, and these are also the experimental study results from different researchers. Okay? So last time we also discussed this about for the calculate the reset pressure. Okay? So when you calculate the volume flow rate for capillary restrictor or for the olympus restrictor, always you need to calculate the reset pressure, okay, PR. So in this section, in the next section, we will tell you how to calculate the PR by using this equation. So the PR is the reset pressure. Okay? So using this equation, the volume flow rate passing through the restrictor will be equal to the volume flow rate passing through the bearing tank. Okay? So by this equation, you can calculate the recess pressure for circular bearing and oil natural cylinder. So we can calculate the PR. Okay? So this is for the capillary restrictor. And of course, we have this also for the air bearing. So, and then we have another different restrictor, or this restrictor. We have another equation to calculate the recess pressure. Okay. And last time we also tell you the conclusion. For the capillary restrictor, the PR is not related to the viscosity. Okay? So the recess pressure of the capillary control hydrostatic bearing are independent of viscosity. From the equation, we know the PR not related to lubricant viscosity. So in that case, the capillary restricted hydrostatic bearing is not sensitive. It's not sensitive to change of temperature. 所以我们其实会知道那个从那个油腔压力 PR 的公式就知道 PR 里面没有粘度的变化在里面。毛细管节流的液压轴承其实是对温度不敏感，这也是为什么上一次我跟大家给大家看，大部分南欧或者是东欧的大型液晶压的工作，他们都喜欢用毛细管节流器来设计它的液压轴承，因为那个旋转工作台的面积非常大，油箱面积很大。它其实摩擦产生的热会非常高，所以它要选择一个节流器是对温度不敏感的系统，才会比较稳定。所以他们倾向用毛细管节流器。所以你就要有一个概念，你的大的液压轴承是不能用毛细管以外。油机大概7、8年前就犯了这个错误。卖到国外的工作台，常常在夏天的时候就不稳定，其实就是因为它的节流器对温度太敏感。And for the Olympics was hydrostatic bearing using Olympic restriction. You see, in this PR equation, you see the viscosity. Okay? So in this case, for Olympic restriction, the hydrostatic bearing using Olympic restriction, they are more sensitive to the temperature change. 相反的来说，就是这个 PR 的公式里面就有粘度，有体的粘度，所以毛细管的小孔节流器的液压轴承其实是对温度比较敏感，所以如果温度控制不好，有系统不会不稳定。Okay. So the resistance pressure for the Olympic control hydrostatic bearing depends on the viscosity. And last time we also talked about the pressure ratio. Pressure ratio for the hydrostatic, oil hydrostatic bearing or liquid hydrostatic bearing. So the pressure ratio according to data, data equal to PR divided by PS. The resistance pressure divided by the supply pressure. Okay. This is called the pressure ratio. So we have a footnote with O here in the equation. O is the design fuel gap thickness. We have fuel gap thickness here, H. So when we do the calculation, we should first assume you have a theoretical fuel gap thickness for your design. So we put in the O, funnel O, it's called the design toolkit. Okay. Okay. So we have a funnel here. O, this is the design expression. The O is called the design value. But we know the for manufacturing the varies varies the dimension of the vary. You are putting some tolerance on it. So the actual film gap thickness is not always equal to the design film gap thickness. 通常我们设计的时候会假设它一个凸起来的油墨厚度高，但是我们轴承制造其实是有公差的，只要在公差的上下限，其实都符合我们的制造。所以我制造出来的油墨间隙，并不一定会跟我设计时候考虑的那个油墨间隙完全一模一样。所以为了区分，我们就把设计图就把它放一个 O 在下面，所以看到 HO 就表示我是设计，你看到实际的 H 就是我真正制造，就是我讲说我要裁这个板子的长度，比方说我说是30公分，但是我加工不可能只写30公分，因为去放一个公差在后面。可能是正负3公分3mm，所以它实际加工出来会有一个值，并不一定是50公分或30公分，它会有一个实际的油墨间隙我们就是 H， 设计的就是 H， 像我们这个就是针对设计 RO。So the PRO is the value of recent expression of H equal to H naught. So this is the design value. 我们一家轴承我们设计的时候都会假设一个间隙 H 0的等于真正我们设计完，我去制造这个圆形平面轴承出来，我把油打进去之后，它其实会浮起来，那我就有一个实际的高度，所以你要去实测一下它真正的高度，这个假的高度，所以你会有一个 H 0的字，有一个 H。我原来所有的理论推导都是针对理论的间隙，但实际的间隙不一定会完全。这个是不一样的地方。我们其实要去测一下它的高度，有没有高度，有没有间隙。后面我们要去调整它的那个节流器的时候，就是看实际量测出来的有没有间隙去做调整。And this is the value for the air barrier. This is the pressure ratio. The same. With footnote O means design to get. It's the same concept. PL divided by PA. But so last time we talked about the load capacity equal to the PR multiplied by the equivalent bearing area. Okay? So now we know how to calculate the PR. The next step is that we need to know how to calculate the area. Okay? So that we can calculate the load capacity. Okay? So the equation for the load capacity for the bearing height will be equal to the resistance measure multiplied by the bearing height area, equivalent bearing height area. 所以简单的公式来讲，就是我们可以把这个复杂的公式把它变成一个简单的公式，这是我们油箱压力屏障等效的轴承定值，你就可以计算我这个地心压轴承可以承受的负载大小。Last time we talked we discussed I think we discussed this one before. And today we will discuss the different configurations for the truss bearing design. Okay. This is one of the designs for the opposite land bearing. For the for the slide table on the leading guideway, so you have this kind of opposite type truss bearing. So if you have another side in the same opposite type isostatic bearing, so sometimes we have another recent design here. So this truss bearing we call it closed form isostatic bearing. So this is the closed form isostatic bearing. This is the closed form guideway system. So you see, this is the reset for the hydrostatic bearing. We have three resets in one diagram, another three resets in another diagram. Okay? And this is different design. We have two bearing resets in one diagram, and in another diagram we have four resets. So, I mean, the radial direction. Here you have two resets. Here you have also two resets. This is two cross-form guide rail, hydrostatic guideway system design. Okay. This is for the open guide rail design or open guideway design. Okay. So you have only this V-shaped recess here, and this is the two flat one. Okay. So this is called the open guideway design. This is called the closed form. For this kind of a closed form design, you can this guideway system, the hydrostatic bearing or hydrostatic guideway system can reduce the external force in the radial direction. Okay? But for the open guideway system, it cannot resist the external force in the radial direction. Okay? This one is only the guideway system only can resist the external loading from the vertical direction. 开支跟闭支的静压导轨系统设计，它可不可以受侧向力？一般来讲，这个是磨床的才会使用的开支的导轨设计，其他的就是铣床、车床都是用这个闭支的设计。So for our opposite that red bearing design, you have only considered the two bearings and in the vertical direction. Actually, you can also design a bearing in this direction, the horizontal direction. Okay? Like our guide system here. And for the journal bearing, this is for the journal bearing. Journal bearing is uh, we can resist the external force in the radial direction. Okay? In most of the case, for the oil hydrostatic bearing, you have a recess design. For the air bearing, there is no recess design for the job bearing. Okay, this is the difference between the oil hydrostatic bearing and the air bearing or aerostatic bearing. This is because if we have recess design in the air bearing, then your system are prone to the pneumatical hammer stability. 气垫压轴承或者空气轴承通常都不设计油墙在轴颈部，所以有油枪就容易产生 们这边就不考虑这个重压轴或者是混压，这个混压轴是高速运转和重压效应。And hydrodynamic bearings at the scope of our course in this semester. But the difference is that the load capacity for the hydrostatic bearing is not dependent on not dependent on the rotational speed. But for the hydrostatic bearing, the load capacity will be dependent on the rotational speed. And 差别就是静压轴承的承载力是跟转速无关，但是重压轴承的承载力是跟转速有关，没有转速就没有承载力。那静压轴承不是，我只要把公压打开，它就有承载力。So here we have a German bearing design with the four resistors. Okay. So usually you have an even number of resistors in your German bearing design. 通常在地心压轴承来讲，在轴顶轴承来讲，通常都是偶数的流强数量，但也有极少数会设计单数，它是加工负的武器，但是大部分都是偶数，246吧，通常不会2，通常都是4以上，468。So this is the German bearing with a resistance. Okay. So this is the pressure distribution in the actual direction. So this is okay. Well, this should be the lubricant pressure distribution over the resistance in the bearing field. And this is also the pressure distribution over the journal surface. 这个就是压力的分布，一个是在长轴的方向，一个是在轴颈的方向。So the number of A is called the bearing speed. 这个风有点。So this is a special term. So this is A. It's called the bearing length or bearing speed. This is the Chinese name. 它是有特别的名称。我们这本书叫做 bearing length. The called bearing length is in this textbook, but in another textbook, sometimes they will call it bearing speed. but it's the same terminology to discuss the width of the area，就是那个油箱旁边的那个宽度，比较丰富。我们这本书叫 Bearing Length，其他的教科书叫 Bearing Speed，它们其实是讲一样的东西。你们可以写在你们的书上。忘了跟大家讲，下礼拜我们会有小考，so we have a quiz this week。下礼拜上课会有个小考 ，overbook，所以你们带书来，你也可以去印那个投影片，都没问题，只能带纸本。So this is the low capacity for the solar bearing. So you have a vertical direction, low capacity. You have a horizontal direction, low capacity. So we have already changed the equation here. Okay. In your textbook page 42, so there are some mistakes for the original textbook. So you need to change the equation. I think maybe your PDF file already changed the equation. Yes. You change the original sign should be changed to the cosine. Okay. There are a few mistakes for the textbook. So these are one of the mistakes. So there are three mistakes in this page 42. So we have the equation for the load capacity of the external bearing. Okay, we will take a break and for 10 minutes and then we will continue. So 我们先休息一下几分钟，我们再讲这个正规化的部分。好，休息个几分钟。就 take a 10 minutes break. 无因次的数据。所以在你们流体力学里面，第11章就在介绍这个无因次。流体力学会去做因次分析。像我们这个图表就是无因次 ，R 是长度 ，R1 也是长度，长度除以长度，其实这个数字是没有因次，这个也是叫做正规化处理。这个也是一样 ，P 减 PA 这个是压力 ，PR 减 PA 这个是压力，压力除压力它其实是没有单位，所以叫多来这一行，叫 dimension 的这一行。其实我们流体力学常常用这样子的话，我出来的图表这个特性就跟尺寸有关。只要我的形状是这种形状，它的特性就是这样，跟尺寸的大小没有关系。So here we have resistance pressure multiplied by area x. So we have a table. So the group here, W divided by dr multiplied by A is the normal line. We have summarized the data. So this is the normalized data. So in this design group here, you have dimensionless data. For instance, here you have recess pressure at design group J6 divided by supply pressure. So this one is you have the unit of the pressure. This is also the linear pressure. So this number is without any dimension, 就是没有任何单位，所以这个就是正规化的数据，对，全部都是。看像面积除面积，压力除压力，负载值上这个 PS 值上 A， 这个也是负载，所以这全部都是正规化，通过来可以。So this is the name of the curve for the property. So first one is pressure ratio, eccentric pressure ratio, and this one is for the isostatic oil isostatic bearing, and this one is eccentric gauge pressure ratio, and this one applied to the air bearing. And here we have an effective area, AE divided by A with the symbol of A bar. And then we have also load support, the load this bearing can support. Okay. And then we have also flow shape factor using the D5. This is the actual dimension that for this to. Okay. And we also have a flow shape factor for the air bearing using this also D5. And we also have a flow pressure factor. This is the Q bar. And speed parameter. This is called SH. Okay. You have a special name for this one. So this is out of scope discussion in this course. For the hydrostatic bearing, and you have also speed parameter for the thrust bearing tank using this value. And you also have a film stiffness, okay, using the lambda bar. So it's easier for you to express the performance characteristic using the normalized data. Right. So in page 33, we have this. We also have an example 2.1 page 43. By using this formula 2.33, we can calculate example in 2.1 in the bottom of the page 43. So this is the example. And the next section is page 44. It's a formula summarized for the air barrier. The equation for the aerostatic bearing, air bearing, is not derived by step. This textbook will just give you some of the results for the formula applied in the air bearing. So we have some formula here. This is the formula in page 44. So here are some mistakes again. So this one is LS. Events of slump restricted. So that's why okay. This is volume flow rate for the slump restricted. That is the uh, the other result for the blood restrictor. This is the mass flow rate for the circular bearing pad. And this is the capillary restrictor for the air bearing. And this is the orifice restrictor, the mass flow rate for the air bearing. So this is the equation 2.38. Next is rate expression of the capillary restrictor. So we have a rate expression PR for the capillary restrictor. And you have a PR, the orifice restrictor. And next, we have terminology for the virtual reset. Virtual reset is where an area of the bearing neck is surrounded by a reasonable orifice. So we have a third bearing neck, okay? And our entry of a group to create the get of a constant area pressure and real reset. 这是我们有一个虚拟油枪，后面我们其实会介绍。So you can look at the next slide, next page, in the next chapter. virtual reset. So this is the actual reset here. And if we can create an inlet code surrounded in the center, so the effect of the this inlet code would be equal to the reset. So it's called this kind of design. It's called the virtual reset. So virtual means not real, OK？ 所以我们讲的虚拟的油枪，就是像这个。左边的话是我们真正的油枪，把它挖一个凹槽，让它充满了润滑油。那空气头层的话，就是挖了凹槽的话，其实会有气水的问题。所以他们取代的就是去挖很多的空气，挖一整个。那它出来的承载的效果会相当于这个。那我们这种的入气孔的设计的话，我们就把它当做是叫做虚拟油箱，这个也是一样。So this is the same. This is the square bearing pad. So we have the actual reset here. And for the virtual reset, you just drill a hole. And this hole was aligned on the square inlet hole. Okay? So the effect of the low capacity will be equal to the reset one. So 这个负载的效果就会跟实际上有挖油枪的一样。实际上我们是挖一些凹槽，然后连起来就是入气口，打气入气口，我们就是叫虚拟油箱。理论上是可以这样做，实物上是不可行，实物上没有人这样做。想想看啊，每一个入气孔后面还要接那个管线进去，还要接流器。你装一条管线的话，去安排管线就不容易。这个打了这么多孔，要去安排管线，困难度更高。理论上效果是一样，实物上是不会有人这么做，你给自己制造麻烦。而且你这么多管线怎么安排在系统里面，这是一个很大的问题。So we will discuss this virtual reset in chapter 4. 在第四章的时候，我们还会再回来讨论这个虚拟油箱这个议题。Okay. So the following is the example 2.2 and the reference. Okay. So most of the formula, the air bearing, was coming from this first reference cross. It also cross gas purification. Okay? So most of the air bearing formula comes from that book. 大部分机器压轴粉的公式都是第一本书出来的。We have this book I think in Chengkong University and also in National Taiwan University. 这本书其实在成大，我们学校没有，我有引用本， And also here we have another some reference here. Overall, this is also a good summary of design of A variable. Overall，这本书其实也不错，七星那种很设计，有趣。有没有什么问题？Any question so far?下一个我有一个小考9:10啊，上面。So you can bring the paper copy of the textbook and also the PPT file. Only the paper copy. 下礼拜会有一个小考，open book。 你会自己解释一下名词解释，就像这个，我给你写 very late，very late， 你的要写在中文。好，我讲的节流器，毛细管节流器、小孔节流器。什么是油腔压力？什么是供油压力？要请你们准备一下，因为我发现没有这样考不行。有些人上到期中考前都没有去念书，还有人期中考来跟老师借书。That's so difficult. It's all in the one day. 好吧，我们休息个10分钟啊。We take a break and we'll continue. We'll continue for chapter 3. 下节课我们会讲一下第3章。So in this chapter 3, we are talking about the power, temperature rise, and the shape optimization. So for hydrostatic bearing, moving in very small film gap thickness. So there are generating some heat during the movement of the bearing due to the viscous friction of the lubricant oil. Okay. So for the temperature rise discussed here, the hydrostatic bearing, mainly for the oil lubricant, oil hydrostatic bearing. For air bearing, because the viscosity of the air is relatively very small, and the air will be escaped to the air in the air will be escaped to the atmosphere. So normally we can ignore the temperature rise for the air barrier during running in high speed. Okay? But for oil hydrostatic barriers, you should always consider the temperature rise because the viscosity of the oil lubricant will generate tremendous heat during high speed motion. So the calculation of the temperature rise is very important and in the oil hydrostatic bearing. So in, in order to estimate the temperature rise, we need to calculate the friction power. The power here is the friction power for the hydrostatic bearing. Okay. So that we know the overall heat generation during the motion. So in the pressure supply system, we can include the cooling refrigerator design inside the pumping supply system. 那一定要轴承的话，就是我们通常是在2U 左右，2U 到3U 之间的那个油墨间隙是2，20两条了，所以它其实会有产生很大的摩擦，因为流体是润滑油的流体是有粘性，它会产生流体摩擦的发热。所以我们这边的功率其实是计算这个，一个是胖骨的功率，另外一个是轴承摩擦的功率，两个加起来就是它的总功率。就是有一定要轴承工作的时候，它会产生的热，就是用这两个加起来，一个是胖骨打油的时候产生的功率，另外一个是轴承面风油边摩擦的时候产生的摩擦功率，两个加起来就是它的总发热量。所以我们要设计冷冻机器的，我们要知道，轴承在运动的时候，它产生的总热量是多少，我才可以去设定冷冻机的功率。就像我们，你要买冷气，你要知道房间的大小、房间的尺寸，然后另外到底是不是顶楼，是不是有额外的日照，才有办法决定冷冻你有多少热在我的系统空间。那当然我们会去预估那个，因为我们的润滑油，如果是温度上升，其实粘度会下降，粘度下降的话，承载力就会下降。So the temperature influence will affect the viscosity of the lubricant. So while the temperature rises, then the lubricant viscosity will be dropped. Okay. So in that case, when the viscosity of the oil lubricant is dropping, then the low capacity of the bearing will also drop significantly. So that we need to also estimate the temperature rise. So we have a formula to estimate if we know the temperature rise, temperature increase, and then we can calculate the lubricant Also, in this chapter, we will define the bearing, low speed or high speed bearing. Okay? We are using some index to define. And also, we will also introduce the concept of the bearing shape, the shape of the bearing. Okay? 所以这一章其实是为了下一章做准备，介绍高速轴承或低速轴，另外介绍发热量，介绍总功率。So for the friction power of the bearing, you need to have a bearing pad area in order to calculate the friction power of the bearing. I just So in next chapter, chapter 4, we will introduce you how to calculate effective or equivalent bearing pad area. So in here we have some important formula for this chapter. The first one is pumping power for your power supply system. So this is pumping power will be equal to the supply pressure multiplied by the flow rate. So we always calculate the volume flow rate for the bearing. If we have several bearings, so the flow rate can be added together. So we know the overall volume flow rate for the bearing multiplied by the pumping power, supply pressure, then we will have the pumping power for the hydrostatic bearing. This is the next one is for the calculation of the pumping power of the bearing. And another case is the calculation of the friction power between bearing surfaces. So we have a bearing surface for the bearing length. Okay, so multiply with the moving speed of the bearing, then we will have a friction power of the hydrostatic. So by adding these two together, the pumping power HP and the friction power HP, then you will have an overall power generation during the bearing movement. And we also define an index called the power ratio, which means it's the friction power divided by pumping power. We're using the K value to classify the bearing into the low speed bearing and high speed bearing. We're using this power ratio to define the bearing classification over the speed. 所以我们会有总的功率，就是这个 HP 加上 H。那另外我们定义一个叫做功率比，功率比就是我的摩擦功率跟我的胖子的功率，那个 K， 我用 K 值来做分类，这是我的。定义我的那个轴承，就是到底是 低速轴承或高速轴承都用来定。Okay. So we also using the formula to calculate the temperature line during the air removal. We assume all the heat generation will be transferred into the oil loop, and then we can calculate the worst case scenario, the temperature rise in the oil loop. Okay. By ignore the radiation and the conduction, so only consider the convection. Okay. So in that case, we can estimate, calculate the temperature rise for the oil loop due to the power generation. And here we have also one formula to calculate the friction area of the bearing using for the calculation of the friction power. So this is the outline of this chapter. So first we will introduce you the pumping power, then the friction power, then the ratio of friction power to the pumping power, K. And we want to estimate the temperature rise for the oil lubricant. So then we will have some design objectives for the hydrostatic bearing. So the first objective to design is the minimum power for the hydrostatic bearing design. Okay. And by using the K ratio, the power ratio K, we can classify the hydrostatic bearing into low speed bearing and high speed bearing. And then we will also use some of the speed parameters, SH. Discuss about the optimization, plan non-recessed hydrostatic bearing. Okay. So first is the calculation of the pumping power. So pumping power is the power to pump the fluid or lubricant through a barrier. Okay. In that case, the pumping power can be using this calculation of the pumping power can use this formula. So it's the supply pressure, the oil lubricant supply pressure multiplied by total volume flow rate. Okay. This is for the oil hydrostatic bearing. For the air bearing, they using this formula. So this is the first formula we are going to use for calculating the pumping power for the hydrostatic bearing. So for your hydrostatic bearing system, if you have a four set, you should add in the volume flow rate for each bearing head together, and you have an overall volume flow rate for the isostatic bearing。所以我们要去算那个系统的一千压轴承总流量乘上它的供油的压力。如果有4个轴承，我们就要算4个轴承的流量加起来，乘上它的风压，这是它的盎的功率。The second formula to introduce you is the friction power. The friction power is power to move the bearing. So when the bearing is running in motion, then you will have a friction power. It's a viscous friction between the oil lubricant and the bearing surface. So the friction force for the viscous isostatic bearing surface is using this formula. So the friction force will be equal to the H multiplied by the friction area multiplied with the bearing velocity divided by the film gauge thickness. Okay. And the total friction power is equal to the F multiplied by the velocity. This will be equal to this equation. So here is the friction power of the bearing at service. Here are some of the details to estimate the friction power, the area of friction. So we need to calculate the area of friction. It's written in the page 50. So we have the formula 3.4. So this is the formula 3.4. And we also have another estimation of the friction area may be equal to the total bed area minus reset area, 3/4 of the reset area. Okay, this is the explanation, the calculation for the friction area. And the next one is the power ratio. Uh, the power ratio K. So we are using this power ratio K, the K value, to define the low speed bearing and high speed bearing in the classification of the hydrostatic bearing. So if we have K greater than 1, means it's high speed hydrostatic bearing. If K is smaller than 1, we say it is low speed hydrostatic bearing. So we define the K as the ratio of the friction power to the pumping power. So it's friction power is greater than the pumping power, which means that this bearing is a high speed bearing. The friction power is smaller than pumping power. This means that K is smaller than 1. It is the low speed hydrostatic bearing. And we also have another definition for the total power, the total heat generation. We can use this formula to calculate the total power generated operating the hydrostatic bearing. So total power equal to the pumping power plus the friction power. So the total power can be using this also this formula. Okay, this can change to this one because we define the K equaling a change divided by HP. Okay. So the temperature rise will be proportional to the value, the power ratio K. Right. So the temperature rise will be proportional to K. So this definition can be applied to the hydrostatic bearing as well as the air bearing. So we use the power ratio to classify, to distinguish the hydrostatic bearing, either in high speed bearing or low speed bearing. So 用公里比这个 K 来定义那个高速轴承或低速轴。高速轴承的话，就是 K 大一点就叫高速轴，K 小于1就是低速轴。Here we also have some comment here. For most of the aerostatic bearings are low speed bearings, which means bearing friction power is relatively smaller than the pumping power. So consider they are low speed. In that case, usually we didn't consider the temperature rise for the air bearing. Okay? 通常我们把空气轴承当做是低速轴，通常我们不会考虑空气轴承在运转的时候的空气的温度上升，上升。So most of the air bearings are considered low speed. Here we have some summarize for the suitable operating range for the K value. So K, if K is smaller one, which means that the isostatic bearing or aerostatic loading at low speed or moderate speed. Okay? So if the K is equal to 1 to 3 means it's a high speed bearing or optimized hybrid isostatic or aerostatic bearing. So if the K is greater than 3, K is ranging from 3 to 9. This means that it's a high-speed hybrid plane isostatic bearing or aerostatic bearing for higher load. Okay? So we're using K equal to 1 to distinguish the low speed and high speed bearing. Is there any question for this? So far we already discussed the pumping power, the friction power, and the power ratio. Next time, I think we don't have enough time to express the calculation of the temperature rise in oil system. So we will discuss afterwards. Okay? So far, do we have any questions? So chapter 3. So these are the summary of the important focus in this chapter. So next time we will discuss the temperature rise for the oil, and also we will discuss the shape optimization for the design. So we have some design tips design objective for minimum power, which means that it's a minimum total power for running the hydrostatic air. If this is the design objective, which means that the bearing will run in very low friction power, low pumping power. Any questions? 有没有任何问题？ So don't forget we will have a quiz next week. 有没有什么问题？我们下礼拜会有一个小考，open book 可以带你的日本的教科书跟投影片，日本记下来。有没有什么问题？如果没有问题，我们要下课。所以是 open book 考试。If there's no question, I will see you next week. Okay? 下课了。